Welcome everyone. This is a tutorial basically showing how to create a more advanced parametric loft. In this case we get asked quite often how do you do a little bit more complex shapes in IronCAD and specifically on lofting geometry. And typically in IronCAD you would just use some profiles and guide curves and build a loft and just edit that as a will to make your changes for your model. But if you wanted to make it parametric, it may be actually better to build this in a structured part than it would be in an innovative part, just because you have to maintain all your relationships to all your curve profiles for your guides, for example, or your center lines, and then where your positioning of your profiles. This can be done, but it's a little bit more tricky to set all those alignments in the innovative part. So I was going to show you a video here how you can do this in the structured part and actually how easy it is to do this. So I will go ahead and go over to a new scene here, and we're going to go and create a structured part. And to do that, we'll go down our bottom right hand side and make sure our creation type is set to structured part. And we're just going to create a new part under the assembly tab. We can just create a new part, and let's just go ahead and make it active. And what active means is basically anything that we create, whether we drop shapes from our catalog into the scene, or if we draw sketches or 3D curves, they all become a feature underneath this particular part. And the first thing we're going to go ahead and create is our Loft Centerline. That's going to be our main driver for our, our height or our width of our profile. So we'll just go ahead and start off with building a sketch. We do that by going to the sketch ribbon and hitting on 2D shape. And in our case, we're going to start with a plane here. So let's just go ahead and say a plane. And we can pick that, and the origin automatically comes into the origin point of the plane that we selected, or this datum plane. And in our case, we can also change the orientation by switching the reverse X or reverse Z directions inside of here. In our case, I have it pointing to the left and going up, which is fine. You can change that around however you like, but this is something we'll start off with. And we'll go ahead and create that sketch plane. Go ahead and draw our profile, and we'll just simply draw a polyline to draw basically the outline here. And then we'll add a fillet for the curve to be our center line. And I just kind of drew this in space just to show you some things that you want to do. In order to make this thing drive correctly, we want to make sure that this is always going to be vertical. So we'll go ahead and lock this constraint, or we could apply a horizontal or vertical constraint on these elements, but we do have these indicators that we can simply lock to apply those constraints. And then we also want to add our driving dimensions. So we can also drive, this would be our left dimension or our width dimension. We just pick on our curve, place the curve, that's fine. We'll pick another one over here for our height and place it, and then we'll pick our one for our arc value. We can turn that command off. And notice I put this line off here in space a little bit just to show you that even though you put driving dimensions out here, if you edit them, you may not know which way they're going to drive. For example, I make that 5, you can see it drove down to the bottom, or if I edit this, it could drive the whole thing to the right or to the left. It's up to the solving system to make that choice. But what we can actually do is actually move this point up to our origin point of our sketch and actually apply a fixed constraint right on that point. And you'll notice our profile actually comes fully defined at this stage. So it means that this is going to be our starting point. If I edit this, it's going to go up. If I edit this one, for example, go ahead and make that one 5, it's going to go to the left in this case. What we also want to do is just go ahead and enter our parameters here. We can see that these all get a default name, but it's always a good point to just go ahead and name them so we know what we're working with here. We'll call this one our width. Oops, I'm going to type in here to click first. This will be our width. We'll call it for driver. And this one is our PD2. Over here you'll see it highlight. Again, this is going to be our length driver. And our last one is our radius. We'll call it center R inside of there. Let's just go ahead and just make that a nice 2 value for now. Doesn't really matter. Okay, so now we have our base center line for our profile. Now we just need to draw the remaining geometry. So let's go ahead and finish our sketch and apply this. Okay, now at this point, let's go ahead and draw our profiles that define our loft shape. So let's go ahead and create another 2D shape. And this is where we can start putting some intelligence into our profiles, or the positioning of these profiles, so we don't have to add a whole lot of constraints. In this case, we want to go ahead and add a profile that's normal to a curve at a point. In this case, we're going to pick this curve And we're going to go ahead and pick this as our point that we want to set that location or that constraint for that. And we can set this through point. You can also set arc lengths and things like that, and how far you want to offset it. In our case, we want it right there at the end point, and that's where we want to constrain. And again, it's critical in this case to know which way your x and y is, because we need to make sure that our x will be pointing to the left and our y is up out here when we create our next profile. But once we have this set, we can go ahead and apply that so that now our profile is centered directly on our shape. Next thing we want to do is we want to draw our curve in our arc. So we'll just we'll just go ahead and just draw it up here in space just to show. We'll just draw an arc profile, and we'll do a center point. And let's draw our arc inside of here, and we can go ahead and add a smart constraint to drive that guy. And you notice a nice thing about our system, or our profile, if we edit this guy, so say we make it 1, for example, notice it automatically does this symmetrically. So if we make 1.5, it symmetrically drives itself for what we want it to adjust. We don't want it to grow one side or the other. Otherwise, we'd have to put more constraints to make sure that it's aligned to this center point. In our case, since it's growing symmetrically, we can simply just select these curves, hit our move command, go from our center point, move him down here to our other location, and apply that, and he is actually now in the right location. And we can save ourselves another step here. We'll just go ahead and copy this. We'll hit finish inside of here, and now we'll create our next sketch, which on the opposite end, same thing, normal to curve at point. In our case, we're going to make sure you don't have any curves selected right now, because this is not what we want. But we'll go ahead and pick this curve as our curve selection. Sorry, our curve selection is this one. And our point that we want is going to be here. And we want it to go through that point. Okay, so we pick our point on that curve, and we notice our y is up and our x is to the left or right. And of course, we can adjust that using these two settings here on the left. And we make sure every time when your instruction part is we want to fix this to the reference. So whatever we're setting here, these are constrained to this. So if this curve moves, this profile is going to move with it, and that's what we want. So let's go ahead and apply that. And now we can paste our geometry, and it comes in exactly where we want it. And now we are set up on this end. So far, so good. Last two things we need to actually build our drivers here. And this is our arcs here on the side. But just before we get to that, let's go ahead and make sure everything is working. So we'll go into our parameters. We can see all of our parameters here. Here's our width D. These are the radius values that we created on the smaller arcs. We can give them a name if we want, but let's just go ahead and adjust this. Let's just make this 2.5. This one 2.5 as well. You can see our arc's a little big, so let's just make that 1, just to make it a little smaller. And we can go ahead and hit apply. You can see everything's moving. We hit OK. There's our profile. So we can see everything's moving as we expected inside of here. Okay. So now we need to create our next profiles. We'll go ahead and create another 2D shape. These will be our guide curves for our loft. And again, in this one, we're just going to actually create it on we'll create it actually on a plane. We'll create this plane here, and we can actually pick the origin point to be our point of our curve, so it's actually out here on the end, which is kind of nice. It makes it a little bit easier for us to define our location. Again, make sure our fixed reference is on. Go ahead and place that. And here, once again, we'll just draw our path. And I'm intentionally leaving it off there so you can see what's going to happen when we create this. Again, we follow the same steps as we did for our center line. We'll just lock these up, put some dimensions only on the arc this time, because these, in this case, are going to be driven by our movement or our size of our shape. Okay, so in this case, what we need to do is this point needs to be associated to the end point of our profile, so that when it changes, you'll see that the profile will adjust and the length will change with it. To do that, we simply just use our Coincident constraint tool. And what that allows us to do is to pick this point and allows us to pick the end point of our profile. And you'll see when that gets created, it's telling that this is defined fully on this curve because it's horizontal and it's locked in this reference. Same thing will apply when we pick the other point. Now this one becomes a little bit tricky. You need to make sure that you are hitting the right point. You want to make sure you don't you actually hit the profile point here, so that it is actually going to adjust with that profile inside of here. So now we have that one defined fully. We can finish it and repeat it on the other side. So let's go ahead and do that. Same exact steps. Create a 2D shape. We do it on the plane. Pick the plane. Our origin point is going to be out here. And we'll go ahead and finish that. Draw our profile again. And we'll just lock these up. And our fillet in here. And then we'll just put a constraint on our fillet. Do our coincident constraint. Again, hit this point up here. And we will hit this point over here. See that it adjusts for us. And we can finish that. So now we see that everything is set up here. And let's just do a quick test to verify everything is set up. Go back to our parameter table. And we can see again, we can change our drivers here. Let's just make this 3, make this one 3, just to see everything is driving. Make it back down to 2 here. You can see it all adjust back down. Since we need to adjust the size or the radius values here, let's go ahead and put those in as well. And we know that our center radius is currently 1, and we'll make these radius values here. I'm not sure which one's which, so we will actually just go back into the sketch and put a name there so we know what it is. This is the small radius. And we'll edit this one as well. This is the large radius. Okay, so we know those 3 values. And these, of course, if we look at our parameters, they're going to have P1 or PR1, PR1 here for these values, but they're going to be the same. So we're just actually going to call this the size 1, size 2, and simply we'll just make this one the same size for now. They could be, you could make them independent, but in our case we're going to make them equal. So if we make this one 2 for, let's make this probably too big, let's make it 1.5. We can see those change. All of our curves are adjusting accordingly to that change. Let's make it to 1. We can see all those adjust. Okay, so essentially we've got this thing fully defined and driving. So very minimal constraints with these coincident constraints, single radius values changing it, and essentially you have 2 drivers, and you can adjust your arcs based on the size of your geometry. You can do parametric equations. For example, this one could be half of it. This could be 1.5 size there, so that you can adjust this fully. But now all you have to do is essentially create your loft geometry, which is going to be our profile to profile, and then we're going to have our center line curve. It's here, and then we can actually add our guide curves, 1 and our other one 2, to apply, and we can see that we have our shape again. We can deactivate all, so we don't see those planes anymore. Essentially now we have our drivers. We can parametrically control this. We can tie this to other things as well. Maybe want to make this 3. You can see we can actually drive our loft that way now. And then we can adjust our radius values or our size of our profiles. A little bit bigger, make this a little longer. Side there. Okay, so essentially a very simple way for you to create these lofted shapes that has some intelligence to them with the parametrics. And of course, all your geometry you can always store in a catalog for reuse. So if you wanted to reuse this geometry, drag and drop it into a catalog. And since we are building all the constraints underneath this guy as self-contained, when you drop them back out, you now can drive both of those guys. You can see all the parameters will show up here for both parts, but if you select on one, it'll show you the parts for either one of those. So you can drive either one of them independently. In this case, maybe make him a little bit bigger. We can drive that one bigger than the other. And you can always do things like design variations as well. in your model, if you wanted to make a few variations of this geometry, you can actually add driver parameters at the part level. In this case, we have all these here. We can go into our add-ins here, and we can find our design variations and add a design variation to it and edit it. In this case, it's looking for drivers at the part level, so we need to add some drivers to actually drive this geometry. So what I meant by that when I went in the first time is if you uncheck this option and you select your part, we're actually on this part down here, we add our design variations. Notice there's no drivers at the top level of the part. And you can essentially add parameters here to say maybe we'll add a length value. Let's make it 4, and we'll add another parameter, width. We'll call it, oops, we'll call that value 4 as well. And these are the ones that you're going to use as your main drivers of all your parameters below it. So if you turn this on now, you can set this one as your len. This one's going to be our width value. So those are drivers now. We hit OK. We can go into our design variations and edit it. You'll see those two appear. And you can then now create your design variations. So this one's our, rename it. This is our size 4 maybe. Create a new one. Call it size 5. And we'll set the value for that one to be 5, of course, both of those. We can put part numbers, descriptions for different part numbers, even a different color if we wanted to drive that guy. We hit OK to this. So now we have two design variations driving this. We can go to 5. You can see it adjust. If we go back to 4, it should adjust back down to that 4 size for us. Oops. Forgot to set the variables for the 4. Got to set that in there too. So make sure you set that when you apply those so that it'll adjust correctly. There we go. We'll go to 5. Now if we go back to 4, it will adjust properly. So there you go. A very simple way to build those. Again, you can drag this one into the design variation into the catalog, and when you drop it out, the user will have easy access to decide which size they want. I want the size 5, apply it, and they get that on drop. So a very simple way to create your your family of parts here inside of IronCAD with a complex loft capability with center lines, guide curves, and profiles. Hopefully this will help you guys get a little bit more advanced shapes in your geometry. Feel free to send more requests in, and we'll help create some more videos for you. Enjoy.